Hello folks. Okay, this time I want to talk about Lab 4. So playing with the debugger, playing with the profiler, playing with a little bit more of the project code. So we'll see how we go here. Let's see, what did I want to get into? Let's take a look at just kind of an overview first. So the usual idea, you're going to be going through, pulling a bunch of changes that I've made to the repository, merging them in with your own. I don't think there should be any big complications with merging the new changes this time around. I'll talk about them in a sec. You're going to go through and fix 2 of the bugs that you found in your Lab 3, 2 of the functional ones, and something more on the interesting side, not a trivial one if possible. Again, you're going to be going through and doing an exercise with Gdb and the project code, an exercise with valgrind and the project code, and that's going to lead you to fixing another bug, a memory leak that's in the code, and then an exercise with the profiler and a script I've provided to go through and generate some test cases. So that's pretty much the idea, and then you're going to be pushing the repository, of course. So usual drill, you're going to be going through and pulling the changes that I've made to the repository and merging those in with your own. In this case, what have we got that's interesting in the new one? Let me just see what we can pull up here. So you should see now there's a new gentest.sh. So this is going to be a script that I'll talk about a little later on. Most of the stuff is going to be the same. The makefile has been updated, and I'll talk about that in just a second. Of course, the index.html is just a copy of the lab web page, but the other interesting bits are in the source directory. You'll now see, ooh, what have we got? That instructor.o shouldn't be in there, I don't believe. However, it should still be your copy of item tree and your copy of demo, but now there's also an address.cpp and the item.cpp. So you now have pretty much the whole source code for the demo program. So those have been added, and if you take a look in the makefile, you'll see that the makefile has been updated so that it now builds based on those. And there's a few other tweaks and whatnot. I would like you to use the new makefile that's been provided as opposed to the one that you modified for Lab 3, just so I make sure I've got everybody using the same flags and whatnot. Let's see. So we've got our makefile, we've got our code, and you're going to do the usual process of doing a make clean and a make, and hopefully it will go through and build everything correctly. And you can go ahead and run the demo program as usual. Oops. Helps to actually run the right executable. So, usual idea. All right. So, once you've got that brought in and merged together and added and committed and everything seems to be okay, I want you to pick 2 of the more significant bugs from your functional defect list from Lab 3, figure out what the problem is, and fix them. Make sure your fixes adhere to the project standards and all that sort of thing, and update any comments and whatnot so it matches the revised code. But again, just an exercise to get you working with the project code a little bit. And then I'm going to get you to, and of course, do an add and commit, separate adds and commits for the first bug and separate adds and commits for the second bug. Then I'll get you to go through and do a bit of a debugging exercise. So again, this is using Gdb, so we have to compile for Gdb, which means using the -g flag. So the easiest way to do that is from your from the root of your repository, go through and do a make clean. We want to make sure we recompile so that all of them are using the -g flag. And again, we want it to compile, but we want it to use, instead of the warnings that were given, we want it to use -g as well as the wall and wextra. And it should recompile everything and using those flags. So now you've got it recompiled in a way that's going to work for the debugger. Now, what I'm going to get you to do is to go through and sort of follow step-by-step instructions for the debugging, but I'm going to get you to record it. And the program that does the recording is called Script. So I'll let you follow the actual instructions that are in the Lab 3 page, but just so you have a look at Script, you can say Script, and then you give it a file name, my recording experiment. So again, this isn't something you're going to do for the lab. This is just so I can show you how this stuff works. And what it's going to do is record everything I type. Blah, foo, everything that appears on the screen. And it's going to keep recording until eventually I type exit. At which point it tells me that it's done recording, or that the script is done, and it tells you what file it stored everything in. So if we have a look in that file, you'll see that it actually recorded everything I did. Unfortunately, the special characters and whatnot, you know, if you use backspaces and things, then it's going to come out looking kind of funky. But it's got a recording of everything that you did and everything that appeared on screen. So when you're doing your GDB session, this will record all of the commands that you enter and all of the things that GDB showed you on the screen. So it is really useful to just kind of record an interactive session, and that's what I'm going to get you to do as part of Lab 3. So again, if we have a boo in here, it asks you to recompile, then it asks you to start recording, it asks you to go through the steps for the lab, and then at the end, well, the quit is to get out of GDB when you get to that point, and the exit is the one that stops it recording. Now it records everything that you type in between your script command and your exit command. So please only do the steps, record, just do the steps in the lab here in this part of the exercise, right? You're just recording this GDB session. So do those steps and stop recording. I don't want to get a recording of all the other stuff that you're doing that's unrelated to this particular piece of the lab. So that's one thing. When you're recording, just start recording, do this. It's a short exercise, so it's not a big deal. Short exercise, record it, stop it, and things should be good. Remember to add and commit that file once you're done. And the other thing that I'll ask you not to do is to use any other programs in this window while you're recording in it. And I'll show you why. So let's do that same thing again. I'm just going to record over top of my recording here. So I start recording, and then I do something like, I don't know, I look at a file content. I do vi foo or some such thing. Blah, blah, blah. So I edit a file or some such thing. And then when I'm done, I quit, and it's in my recording. So now if I look at this, I get all sorts of garbage that Vim produces because Vim is doing a whole lot to your screen other than what you're seeing. So I would really rather not see all of that kind of junk inside your recording. So please don't do anything other than the actual GDB instructions while you're recording. Okay, that's my speech. Thank you. And now back to our regular programming. All right, so you're going to do this GDB exercise, and then you're going to go through and do an exercise with Valgrind as well. And again, this follows on from the kinds of things we were looking at on the lectures for Valgrind. So you're going to run through, you're going to turn leak checking on, and you're going to run the demo program. And all you're going to do is run the program, create a tree, insert a node, and quit. And then have a look at the output that Valgrind produces. And again, follow the instructions in the lecture for Valgrind to see how to look at the output for it. And you're going to see that it will tell you that a bunch of information was definitely lost when you did this. A bunch of bytes were lost. So there's a memory leak in there someplace. If you try this again and insert 2 nodes and then quit, you'll see twice as much got lost. If you insert 3 nodes and quit, you'll see 3 times as much was lost. So there's some kind of information associated with those memory nodes that's getting lost. So what I would like you to do is to start digging in and see if you can find the problem. And just as a big tip, if you start in item tree and look at the destroy method, that'd be a really good place to start looking for the problem. It's not a complex fix. This wasn't meant to be a huge, ugly, gross debugging exercise, but just so you get a bit of a play with it. So, and as usual, do adds and commits especially for that. And then finally, I'll get you to do a profiling exercise with gprof. So again, usual idea, do a make clean. You have to do a special compilation for gprof, and remember that was using the no positional independent, no replacing my code with built-ins. Do your compilation, and then this is where you'll wind up using that script that I provided in the repository. So this gentest.sh generates a test input file for your for the demo program, and basically you give it a number and it produces that many random nodes to insert into the tree, to insert into our item tree. So basically you run gentest. In this case, we're getting it to generate a test case that's got creates a new tree and does 1,000 inserts, right? Generates 1,000 random items. And so this gives us a chance to go through and run the program on a bigger test case without having to do it all manually. And again, we're going to use that for profiling the program, for seeing what kind of performance that we're getting, seeing where the CPU utilization is going as the program runs. So I'll get you to try that out, and I'll get you to try it again with a much bigger file, so say a size 5,000. Do some adds and commits for this. Have a look at what's going on. So I want you to go through and just get the experience of using gprof, looking at the results, and seeing what's going on. All right, and as usual, that adds and commits for all. Don't forget your final push, and we should be good. All right, I will leave it there.